In today's video, we'll be starting chapter 7, that is triangles of CBSE class 9. In this video, we'll cover an introduction to triangles and we'll also learn what is congruence and what is congruence criteria for triangles. We'll also solve exercise 7.1 questions from NCERT book. Before learning about congruence and congruence criteria for triangles, let's understand what are similar triangles and what are congruent triangles. Let's take a look at these two triangles. Both of them are right angle triangles and both of them have same angles, that is, this is 90 degrees, this is 90 degrees, this is 45 degrees, this is 45 degrees. However, the size of these triangles is different, that is, the shape is similar, angles are similar, but the sides, the length of the sides is different. So these triangles are similar, not congruent. Now what are congruent triangles? Let's take a look at these two triangles over here. They have the same shape, same angles, and the size is also same. Length of the sides are same. That is, if I were to place this triangle over this one, they look exactly the same. They are totally identical. So these triangles are congruent triangles. Now let us look at some aspects of similar and congruent triangles. The first aspect, as we discussed, is shape and size. Similar triangles have same shape but may differ in size. Congruent triangles are identical in both shape and size. Sides. Corresponding sides are proportional. In similar triangles, you have to have corresponding sides as proportional. What is corresponding side? If I am starting from here, I see this side. So this side and this side should be similar. Then going clockwise, this side and this side should be similar. And this side and this side, they can be proportionate. Here proportionate is, this is 5 centimeters and this is 10 centimeters. That is, this is double of this small triangle. So they are proportional to each other. However, in congruent triangles, corresponding sides are equal. Let's look at side 1, 10 centimeters, 10 centimeters. Side 2, same. Side 3, they have same size. That is, they have the same length for their sides. So these two are congruent. Angles. In both similar as well as congruent triangles, all corresponding angles should be equal. Let's take a look at some criteria for congruence of triangles discussed in 7.3 in the NCERT textbook. First criteria is the side angle side criteria, which is two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and included angle of the other triangle. Taking a look at two triangles here, ABC and PQR. So corresponding sides, side angle side. So this side is equal to this side and the other side is also equal to this side. Included angle, that is the angle between these two sides, should also be equal to each other. When this criteria is met, I can say according to SAS congruence rule, this triangle ABC is congruent to triangle PQR, and this is the symbol we use to represent congruence. So the symbol is simply an equal to symbol with a sign like this on top, which means congruence. So when we are talking about side angle side congruence rule, we also have to remember that angle side side or side side angle are not valid for congruence. For example, if these triangles were to be equal in angle side and side or two sides and one angle, this criteria is not valid for congruence. Why is that? This is because these type of triangles with one angle and two sides, for example, this can be one angle and this can be two sides, or there can be this side and this side as well. So in this case, we are able to produce two triangles that might not be entirely identical to each other. So that is the reason these two criteria are not valid, and SAS produces uniquely identical triangles, and that's why that criteria is valid for congruence. Next criteria is angle side angle congruence rule. This says if two triangles are congruent, if two angles and the included side of one angle are equal to the two angles and included side of the other triangle. Let's take a look at this. Again, here I have triangles ABC and triangles PQR. Two angles. So angle B and angle C over here are exactly equal to angle Q and angle R respectively. Now the included side, that is the side that is present between these two angles, here BC and here QR, should be equal to each other in order to use ASA congruence rule to say that triangle ABC is congruent to triangle PQR. The next congruence rule is angle-angle side congruence rule. Two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. Looking at these two triangles over here, ABC and PQR, two angles and a corresponding side. So it does not have to be an included side in this case. It can be a side next to any one of these angles that can be equal. Here angle B is equal to angle Q, angle C is equal to angle R, and AC, whose corresponding side is PR, are equal. So I can use AAS congruence rule in order to say these two triangles are congruent. Let's start solving exercise 7.1 questions using the knowledge of congruence of the triangles that we just learned. First question says, in quadrilateral ABCD, AC equals to AD, AB bisects angle A, show that triangle ABC is congruent to triangle ABD. What can you say about BC and BD? So here AC, that is this side, is equal to AD as given in the question, and this line AB is bisecting the angle A. So this angle and this angle are equal as well. We need to prove that the top triangle, that is ABC, is congruent to ABD. Writing down the given information, so in these two triangles, I can say AC is equal to AD because that is given to me. I can also say angle DAB is equal to angle BAC because AB bisects angle A, these two are equal. Now in these two triangles, I have one side and the other side as equal and one angle and the other angle as equal. Let's see what else is equal. So I can say AB, that is this line over here, is common to both triangle ABC and triangle ADB over here. So I can write AB equals to AB, which is the common side. Since this side is equal, I can use SAS congruency rule and say triangle ABC is congruent to triangle ABD. Now the next part of the question says, what can you say about BC and BD? So this is BC and this is BD. We know that when two triangles are congruent, all sides in them are equal. That is, all corresponding sides are equal and all corresponding angles are also equal. So we have something called CPCT, which is corresponding parts of congruent triangles are equal. So these two corresponding parts will also be equal. So I can say BC equals to CD. Second question says ABCD is a quadrilateral in which AD equals to BC and angle DAB equals to angle CBA. Prove that triangle ABD is congruent to triangle BAC. That is ABD over here. We have to prove that it is congruent to BAC, and we also have to prove that BD equals to AC, and we have to prove that angle ABD equals to angle BAC. That is, angle ABD, this angle over here, is equal to angle BAC. So BAC. So we need to prove that this angle and this angle are also equal. Since we have to prove that ABD is congruent to BAC, I have drawn these two triangles separately in order to give us a better picture. So we are given that AD equals to BC. So in these two triangles, these two sides are equal. We are also given that angle DAB equals to angle CBA. So angle DAB, that is this angle, is equal to CBA, this angle. In these two triangles, I know that AB is equal to AB because it is a common side. So I have written that down. Here I can see that two corresponding sides and the included angle are equal. So using SAS congruency rule, I can say that these two triangles are congruent. We have proved the first part of the question. Now, since these two triangles are congruent, we know that CPCT, that is common parts of congruent triangles, we know that these two sides also have to be equal, which means I can say BD equals to AC, which completes the second part of the question. Now coming to the third part, I need to prove that angle ABD equals to angle BAC. So angle ABD, that is this angle, should be equal to angle BAC, that is this angle. So again, these two are also corresponding angles that fall between the same sides. So I can say that these two angles are also equal from CPCT. So the third part is also proved, where we have shown that angle ABD equals to angle BAC. Third question says AD and BC are perpendiculars to a line segment AB. Show that CD bisects AB. So here this particular line AB is perpendicular to AD and BC. So this angle is 90 degrees, this angle is 90 degrees. And we are also given that AD is equal to BC. We have to show that OB and OA are equal. Now writing the given information, AD equals to BC and angle CBO and angle DAO are both 90 degrees. Now I know that AB is perpendicular to AD and BC. This is only possible if AD and BC are parallel lines. So I can write AD is parallel to BC. Now drawing AD and BC as parallel lines and CD as a transversal, I can see that angle BCD, that is this angle over here, should be equal to this angle over here, that is ADC, because of the rule of alternate interior angles. So I can write angle ADC equals to angle BCD, alternate interior angles, and now I can see that these two corresponding angles are equal and the included side is also equal. I can use the ASA congruency rule and I can say triangle AOD is congruent to triangle BOC. From CPCT, that is common parts of congruent triangles, I can say that OD is equal to OC, that is these two sides are equal. At the same time, I can also say OA equals to OB. That means these two sides are equal, which also means that CD is bisecting AB. Fourth question says L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC is congruent to triangle CDA. So we are given two parallel lines L and M and we are given two parallel lines P and Q, and we have to show that these two triangles that are formed by this transversal are congruent. Writing down the given information, L is parallel to M and P is parallel to Q. Let us start by considering L as parallel to M. I have not drawn PQ here for clarity, and let us consider this AC as the transversal. Again, alternate interior angles here, DAC and BCA should be equal. So angle BCA equals to angle DAC because of alternate interior angles. So let's take a figure showing P and Q as parallel lines and AC as the transversal. So I have taken this figure here, turned it 90 degrees and tried to show P and Q only and AC as transversal. Again, taking the rule for alternate interior angles, I can write BAC equals to DCA. So I can write this angle as equal to this angle over here. So from L is parallel to M, we have shown that BCA is equal to DAC, and from P parallel to Q, we have shown that angle BAC, that is this angle, is equal to angle DCA. So this angle over here. So in these two triangles over here, ABC and ACD, I have drawn them here, and these two angles are equal as we have just proven, and AC is a common side, so this is also equal. I can apply ASA congruency rule in order to say that these two triangles are congruent to each other. Fifth question says line L is the bisector of angle A and B is any point on line L. BP and PQ are perpendiculars from point P to the arms of A. We need to show that triangle APB is congruent to triangle AQB. So this is APB and this is AQB, and we also need to show that BP is equal to PQ. Now when we say arms of angle A, so these are arms of angle A on which P and Q lie. So these are perpendicular lines BP and BQ drawn from point B. Let us write down what is given to us first. We are given that angle QAB equals to angle BAP. So this is QAB and this is BAP. These are equal because we have said that L is bisector. In these two triangles, I can also say APB equals to angle PQA because both of these angles are 90 degrees, so they are equal to each other. Now in these two triangles ABQ and ABP, I can say AB and AB are equal because this is a common side. So in order to represent what we have just written here in the two triangles, APB and AQB, AB is equal to AB and angle A equals to angle A and angle P equals to angle Q. So this gives us AAS congruency rule. It is important for you to draw these kind of diagrams and verify if it is ASA congruency or AAS congruency. in order for your sum to be completely correct. Now from this congruency rule, I can say that APB is congruent to triangle AQB. Now from CPCT, common parts of congruent triangles, I can say BP equals to BQ, which means B is equal distance from P and equal distance from Q. Sixth question says, in the figure AC equals to AE, AB equals to AD and angle BAD equals to angle EAC, we need to show that BC equals to DE. Writing down the given information, and then let's see where this BC and DE are. So BC is in triangle ABC and DE is in triangle ADE. So let me draw these triangles separately first. So upon drawing these two triangles, I can see that ABC and ADE are these two triangles and these two corresponding sides are equal. Now I can show that BC and DE are equal if I can prove that these two triangles are congruent. In order to prove that these two triangles are congruent, what is the other information I have? That these two angles are equal. But I need to show that this angle over here and this angle over here are equal. How to do that? I can write angle BAC as angle BAD plus DAC, that is this angle here plus this angle. So this plus this part gives me the whole angle BAC. Similarly, in order to write angle DAE, I need to write it as this one plus this one, which is DAC plus CAE. Now I know that BAD equals to EAC, that is these two are equal. So if I add DAC on both sides over here, I can write angle BAD plus angle DAC equals to angle CAE plus angle DAC. So I can write this angle plus this angle is equal to this angle plus this angle. Now this means BAC equals to DAE, that means this is equal to this, because this plus this over here is nothing but this here, and this plus this over here is angle DAE. So I can say these two angles are equal. Now using side angle side congruency, I can say these two triangles are equal. Now using CPCT, I can say BC is equal to DE. Seventh question says, AB is a line segment and P is its midpoint. D and E are points on the same side of AB. So D is here, E is here, and BAD equals to AEB. So BAD, that is this angle, is equal to ABE, that is this angle, and these two angles here are also equal, which is EPE and DPB. Now I need to prove that triangle DAP is congruent to triangle EBP. So triangle DAP, that is this triangle over here, is congruent to this triangle over here. I have written down the given information, that is these angles are equal. Now AP is equal to PB. I can say that because P is the midpoint, I can say this side is equal to this side. Now I have drawn these two triangles separately here in order to understand which angle or side I can prove to be equal in order to show that they are congruent. Here I need to find two angles which are APD and BPD so that I can say angle side angle congruency. So this angle I can write as DPA equals to EPA plus DPE. So all I have to do is add this angle to this angle in order to get the whole one. Similarly, for the other triangle, I have to add EPD to DPB in order to get the whole angle BPE. Now I know that these two angles EPA and DPB are equal from the given information, that is these two are equal. So from equation 1 and 2, I can say that these two are also equal, because if these two are equal and these two are already equal, that means these two are also equal. So I can say DPA equals to EPB. So I can say this angle is equal to this angle. So from angle side angle congruency, I can write that triangle DAP is congruent to triangle EBP, which also means that this side AD and BE are equal because of common parts of congruent triangles rule CPCT. I can write AD and BE as equal, proving the second part of the question. In the eighth question, we have in right angle triangle ABC, that is this is a right angle triangle and C is the right angle. M is the midpoint of hypotenuse AB. So AM should be equal to MB. C is joined to M So here C is joined to M and is produced to D such that DM equals to CM. So firstly this is equal to this and this is equal to this. Point D is joined to B. Show that triangle AMC is congruent to triangle BMD. So this is AMC. We have to show that it is congruent to triangle BMD. So this and this we have to show are congruent. And the second part is we have to show that this angle B over here is right angle, and we also have to prove triangle DBC, that is the big triangle over here, is congruent to triangle ACB, this triangle over here. And the final step is to show that CM equals to half of AB. Let's start with writing down what's given to us. So AM equals to BM and CM equals to DM. Next, I can write angle BMD, that is this angle is equal to this angle, because these two are vertically opposite angles. In the first question, I was given BMD and AMC should be congruent. Drawing these two triangles over here, BMD and AMC, I know that this angle is equal to this angle because of vertically opposite angles, and here I can see that this side and the corresponding side are equal, and this side and the corresponding side are equal, and the included angle is equal. From SAS congruency rule, we have proved the first part of the question that these two triangles are congruent. From CPCT, I can say angle BDM equals to angle ACM. So I can say that these two angles are also equal over here. This angle is equal to this angle over here. Representing this in this figure over here, you can see I have drawn BD here and AC here, and because these two angles are equal, that is this angle and this angle, these form alternate interior angles. From this, what I can observe that DB is parallel to AC. So far we have proven that these two triangles are congruent and also that these two lines are parallel. Bringing back the figure and representing AC and DB as parallel lines, if I remove this transversal over here and draw two transversals from B to C and A to D, the figure looks like this, and we know co-interior angles should add to 180 degrees. So I can write DBC plus ACB. So that is this angle plus this angle, these are co-interior angles and they should be equal to 180 degrees. But we already know that ACB, that is this angle, is 90 degrees because that is given to us. So from this, I can find DBC by substituting ACB as 90 degrees, thus proving that angle DBC is also a right angle. Now moving to the third part, DBC and ACB over here, we know that DB equals to AC, that we just proved, and we know that angle DBC equals to angle ACB, which is 90 degrees, and BC equals to BC, which is the common side. Now from side angle side congruency rule, I can say that these two triangles are congruent, which is DBC and ACB are also congruent, which proves the third part of the question. In the last part of the question, we have to prove that CM equals to half of this AB. From this congruency, I can say that AB equals to DC. So that is this side and this side are equal. Here, this side and this side are equal. I can write this as half AB equals to half DC. Now, I know that half DC is nothing but CM because this and this are equal. So, I can write that half DC is equal to CM, which makes half AB equals to CM from here, by which we have proved the last part of the question. With this, we have come to an end to the first part of triangles.